In the vast, uncharted expanse of our solar system, a remarkable discovery has been made by the James Webb Space Telescope, JWST. This colossal spacecraft, stationed 1,000,000 miles from Earth at the second Lagrange point, is on a mission to study the composition of the early solar system. During a routine survey, something extraordinary unfolded as it swept through the asteroid belt, a region teeming with ancient asteroids and remnants of the early formation of our solar system. The JWST's Eber-Nurkum infrared camera recorded a faint but unusual object. It was not catalogued, was not listed in any near-Earth object registry, and its trajectory did not match that of any known comet or asteroid. This object was fast, much faster than a typical asteroid, and it glowed not just by reflecting sunlight, but by emitting a deep, eerie luminescence. It appeared to be enveloped in a metallic sheen, and spectroscopic readings pointed to materials not typically found in natural celestial bodies. The object's motion was not chaotic, as might be expected from a piece of debris thrown into space by a collision. Instead, it moved with an odd deliberateness. It sped up briefly, then slowed as it approached a more densely populated region of the asteroid belt. It weaved through the rocky terrain as if avoiding obstacles, a sight that left scientists baffled and captivated. As the object emerged from the inner edge of the belt and passed near the orbit of Vesta, one of the largest objects in the belt, something even stranger happened. The object froze for several minutes. It hung in space, spinning slowly, not in a tumble, but in a steady, balanced rotation, as if scanning its surroundings. Telescopes on Earth were quickly redirected to confirm what JWST had observed, but the resolution of ground-based observatories could not match the detail beamed back from JWST's instruments. The consensus was clear. It was an unusual natural body. Infrared signatures showed high internal temperatures, inconsistent with frozen comets or metal-rich asteroids. Some readings even hinted at energy emissions, structured pulses at frequencies not normally associated with known natural phenomena. These signals carried a rhythm that was not entirely regular, but with enough regularity to attract the attention of scientists and engineers. As the object resumed its course, it veered closer to Mars's orbital path before correcting and continuing on. What appeared to be a shallow, curved trajectory, now out of the plane of the ecliptic. It rose above the normal alignment of planetary orbits, a path that required significant energy expenditure if the object was under propulsion. By this point, speculation had reached a fever pitch. Was this an undiscovered type of comet with highly reflective materials? Was it a piece of ancient debris from a long-lost probe? Or was it something else entirely? Something perhaps out of this world? The JWST, never designed to track fast-moving objects, had been pushed to its limits. Engineers in mission control had manually recalibrated the tracking systems to track the object for as long as possible. Its near-infrared spectrometer detected anomalous compounds along the object's surface, some resembling synthetic polymers, others emitting microwaves completely outside the thermal expectations for an asteroid. The data showed that it was not simply made of rock or metal, but of complex layered materials, some of which showed signs of structural lysis, incompatible with a natural geological formation. By the time the object reached the edge of the asteroid belt, it had traveled nearly 1,000,000 kilometers in a matter of days. It never slowed down once it reached that limit. Instead, it simply changed angle and disappeared into deeper space, now moving on a trajectory that would take it above the plane of Saturn's orbit. JWST sensors eventually lost it due to angular limitations and subsequent positioning restrictions, but not before it captured one last chilling detail. A flash of light from the rear of the object, faint but distinct. It resembled a propulsion system, but not a chemical one. The flare had no thermal signature, no plumes, no dispersion clouds. It was a release of pure, directed energy, something no spacecraft in the world had ever seen. The aftermath of this event has sent shockwaves through the scientific community. First, it called into question everything that was assumed about the predictability of our local cosmic environment. The asteroid belt, long considered a relatively well-mapped region, has just hosted something completely unexpected, undetected until it was deep within. This has raised pressing questions about the error of tracking objects that may not reflect sunlight in traditional ways. There may be other such objects, dark, fast and deliberate, that have already passed us by unnoticed. If this object could maneuver and even stop in space, it implied a level of control that, if not artificial, would require a natural phenomenon so advanced as to border on intelligent behavior. This was not just a violation of orbital predictions. It was a shift in our understanding of what might exist in our own solar system. Scientists have rushed to review data from old telescopes and archived records from deep space missions, looking for anomalies they might have previously ignored. With this new lens, even mundane glimpses and brief bursts of data take on new meaning. Was this object really the first of its kind, or the first one we noticed? What made this event even more convincing was the lack of any tail or trace of debris. Comets typically release volatile gases and dust as they approach the inner solar system, but this object remained sealed, clean, controlled. Its path cut through the asteroid belt with precision, never deviating from a controlled curve, even dodging dense clusters of space rocks. Its speed changed in ways that defied gravitational logic, accelerates, as if driven by an internal force, rather than external gravitational slingshots. As researchers in the field of propulsion physics studied the spectral data again and again, one pattern became harder to ignore. The radiation pulses emitted by the object's movement had harmonics, layers of frequencies nested within each other, not unlike music. It wasn't white noise or thermal radiation, it had tonal properties as if it were unstructured information or running on multiple channels of data. Can an object emit some form of signal? If yes, to whom or for what purpose? Even in the context of natural celestial oddities, this object stood apart. No meteorite, no asteroid, no comet has ever demonstrated such an ordered trajectory, with simultaneously chaotic compositional signatures. What the James Webb Telescope recorded was something unclassifiable by today's astronomical standards. It didn't fit into any of the usual suspects, nor did it fit into such marginal categories as interstellar visitors akin to Oumuamua. Unlike Oumuamua, this object did not tumble, had no random shape, and did not rely on solar radiation to move. Some theorists have begun to consider whether it might not be a probe sent from Earth, but an observer, a reconnaissance ship from a distant source, perhaps even from outside the solar system. The idea is speculative, but the object's silence, its graceful trajectory, and its obvious signature of movement all suggested a level of design. If it was a probe, then maybe it wasn't supposed to land, was not supposed to interact, just go through, observe, collect, and go away. The asteroid belt has just received a visitor, one that was not announced by gravity waves or powerful energy signatures, but which slipped through as silently and efficiently as a thought. It didn't touch anything. It did not disturb the natural order, but it was seen. The James Webb Telescope captured it all. That moment was a break in the supposed boundary between the known and the unknowable, a silent, shimmering passage that rewrote the rules without sound. It may take years, even decades, to fully analyze the data collected during this fleeting window. Every flash of light, every spectral anomaly, every change in trajectory will be shared with a level of scrutiny rarely afforded even to major planetary discoveries. Researchers from various disciplines of astronomy, materials science, propulsion engineering, and signal theory will look at the events from every conceivable angle. These will no longer be just astronomers looking at the sky. Physicists will question the principles of motion. Biologists might ask what such an object could sense or analyze. Philosophers will confront the silence it left behind. This event cast a long shadow. There was never any threat of collision, not because of any danger, but because of the deeply unsettling possibility it suggested that there was something else out there, and it might have already passed us without stopping. Not as an invasion, not even as a greeting, but as an indifferent traveller through our local space.